Today I'm going to speak about the tree, the tallest wooden timber structure in the world. My name is Ole Herman Kleppe. I work for a company called Bob the Builder. Some of you may have seen this cartoons for children. BOB, or Bob, is a corporate housing association. It means we are a member organization. We were founded in 1941. We have 67,000 members, and you become a member to buy an apartment, a place to live. And only members can buy the apartments that we are making, but anyone can become a member, so it's not a problem. In addition, we also do real estate management for more than 23,000 apartments, and we are 150 employees doing all kinds of services for our members, both people living in apartments and people waiting to buy their apartment. First of all, Bob have a very clear goal. We shall take a leading role in urban development. We shall focus on energy efficiency, sustainability, and outdoor environment. This is our mission. This is what I'm trying to do every day in my work. And that is important also to understand why did we do this project, because it is actually natural to do this project as a result of those goals. First of all, a little, where is Bergen? Bergen is located on the west coast of Norway. The west coast of Norway is a windy, rainy, and cold place. If it hasn't been for the Gulf Stream that is coming up here, bringing hot water, it would probably be impossible to live there. Now imagine it. Bergen is an old city. It's 1,000 years old, and it has a small city center, very small city center, with a lot of wooden buildings. So also there we are working seriously with fire protection of our historical wooden buildings in the city center. The tree tower is positioned here. This area was newly renovated, and that is what I've been doing for the last 12 years. I've been responsible for the transformation of this area from being an old place where warehouses and drug dealers go, and to become a lively, modern urban area with apartments. So the tree is placed here as kind of a gateway into this new part of the city, or transformed part of the city. But we had a big challenge. As you can see here, this is a massive concrete bridge. It's a trafficated road, one of the most trafficated roads in Bergen. So when we started to plan the buildings here, the architect said that we need a building that can stand up to this bridge and say, hey, I'm bigger than you. Not to be strangled by it. So we suggested that we should make a 20-story building. In Bergen, there aren't many tall buildings. This is one. We have a few here. But most buildings in Bergen are 6-7 stories high. So presenting a 20-story building was not a good idea. The politicians said no, the municipality said no, so we had to find a way to get our will. And then we suggested that if we make a tree tower, that would be interesting. And that would be a modern way to show that Bergen is a wooden city. So the politician said, yeah, if you make it in wood, that's interesting. And we said that we can make a 10 to 12-story building in wood. And they say, okay, that's good. And then we started out the project, and we found that we can make it 14 stories, 50 meters high. And that would make a world record. So we went back to the politicians and we said that we have a suggestion. We can make a 50-meter high tree tower, and it will be a world record. And you know politicians, they love world records. So then it was possible to make it. But to do such a project, normally when we make apartment buildings, we go to one contractor and we say, can you make these for us, give us a bid, and make the project, make it happen. In this project, we couldn't go to the local contractors and say, hey, can you make the tallest timber building? no one would give us a bid. They couldn't take the risk. So instead, this time, we found out who is the best engineers in Norway when it comes to wooden structures, and that is Sweco. Then we try to find out who is the best producer of wooden structures, and that is Moelven. They have a lot of experience in this. And then we try to find out, is there anyone who can make wooden apartments as a modular box? Make it in a factory. Is someone able to do that? And Kodomaja is a company from Estonia which do this. And then we needed someone to make the drawings. So the company Artec is a local architect who joined the group. So instead of going to one contractor, we found the best possible partners for the project. Not the cheapest, but the best. And the project goals were very, very clear. We was to make a sustainable, cost-efficient, urban, high-rise wooden house. And we should make it as industrialized as possible. We wanted the parts to be produced in factories where they can make it in dry, perfect environments, bring them to the building place and make the house there. So I guess you all are familiar with Lego. That's the idea. Find the pieces of Lego from the professional companies, put them together, make the house. Wooden structures in Norway, in 1994, we had the Winter Olympics in Lillehammer. And Moelven was awarded this ice skating hall. It is actually like a boat, a typical Norwegian boat. And then Moelven managed to find a way to make these wooden structures. So it's a fantastic building. And that was, in a way, why Norway started out this modern wooden technology development. And this is from the Oslo Airport, Gardermoen, when they opened a new terminal in 1997. Again, the goal was to promote Norwegian wooden constructions. So they made these fantastic wooden structures to carry the whole building, roof constructions. And they are made in glulam, glued laminated wood. And that is the technology that Moelven is good at. And then, further on, they started to make these wooden bridges. And you can see here the wooden structures carrying the loads. Wood is strong if you use it the right way. And from this on, here, get to Australia, Melbourne. This is a building called Forte, and it's 33 meters high. This is not made of glulam. This is made of cross-laminated timber, also glued, but in a different technique. And by the time, this was the tallest building you could make out of wood before it would collapse. So we needed to find a way to use the wood differently from what they did in Melbourne. How could we make something taller? And then the idea was, what if you take the structures from this wooden bridge, put it upsides, and turn it into a house, where all the loads are taken in the columns. Because when you have glulam, all the fibers are going the same way. So then it's just a matter of how big you can make this glulam column to take the loads. But also, wood is light material, so we need to strengthen the structure so it should not shiver in the wind, wave like this. And then, here you see an example of these modular apartments. They are made in a factory. They're completed in the factory. So it's almost like bringing a lot of cars to the building site, connect them together, and you have a house. So I believe that in the right conditions, this is a very smart way to make buildings. In the concept phase, we had a lot of ideas. How can we make it? And you can easily see that this would make some real challenges. But we had to test our minds. But we ended up with a structure like this. Quite a strong structure, I'd say. And in the beginning, we were hoping that these wooden frames should be visible to everyone. It's important. When you make the tallest timber building in the world, it's very important that the architecture is so that it tells the story. I'm the tallest timber building in the world, no doubt about it. And if we go quickly back here to Forte, can you see that this is wood? No. We have to make sure that the building itself was telling the story, I'm a wooden building. But then, in Bergen, on the west coast of Norway, it is raining a lot. During 1 year, it is raining between 2.2 meters and 3 meters of rain. We have 270, 80 days of rain every year. So Moelven said that, Ola, you cannot put this into the weather in Bergen. It will rot in a few years. So we needed to put some cover to it, a raincoat. And then we decided to have a glass facade with balconies. And then on the gable walls, we needed something to protect from the weather. But also, people ask, yeah, why didn't you make this in wood? And as Eva told, if you are painted, then you have to paint it to avoid fire. And then you have to repaint it and repaint it and repaint it. And you cannot expect that all the people who moves into these apartments are painters. So we choose a metal cladding, which is supposed to be lasting for a long, long time without maintenance. This is the typical floor plan. And the point is we have 4 apartments here. They are the same, containing of 2 modules made from the factory in Estonia, connected together at the building site. And as you can see, only here you have a room where you are connecting them together, visual. Otherwise, it's taken in the doors. So it's a quite smart construction there. The architect did a great job there. Then we have 1 elevator and a staircase. And people might say, 14 stories and 1 elevator with all these apartments. Well, it was enough, but it could have been more. And then you see here is the structures of glulam on the outside here, all the way around the building. It's a residential building. It has 62 apartments. It's 5,800 square meters, 14 stories high, 15 if we include the parking in the basement, made by concrete to avoid fire spreading. 52.8 meters high from the seaside to the top of the upper wooden constructions. The elevator shaft is in wood, CLT, and it's 15 stories high. And it was very interesting to install these panels and see that you could actually make a 15-story high elevator shaft. Sustainability, why use wood? We all know that when a tree is growing in the forest, it absorbs CO2. It's storing CO2, and it's making wood out of it. So by building in wood, we are actually storing CO2 and using that CO2 for the buildings, instead of concrete, where you have to use a lot of energy to produce concrete, or steel. The same, you use a lot of energy, and to make energy, you have to produce CO2, one way or the other. So wood is definitely a sustainable material compared to concrete and steel and other materials. It also ended up a passive house, which means it's had a very low energy demand. That was not a part of the goal. That was only a result of the solutions. So how did we make it? We stack these modules. You can stack them for 4 stories, no problem. They will stand on their own. You don't need any support for them. And then we make these wooden structures on the outside to carry the loads for the next phase. And then we make a platform of wood in the 5th floor here. Make it of glulam structures. And then we make the platform, then we can start over again. Put these 4 new apartment stories on top. And then the loads from this platform is taken down to the ground by the columns. Now you make a new structure around it, and you repeat yourself. So, and you put the cladding and the glass facades on it. So basically, we make, out of these modules and the structures, we're making 3 5-story buildings on top of each other with these platform constructions. And in the 5th and the 10th floor, we have this, what we call then the power floor, this platform structure. But of course, we also made some apartments in these power floors, very unique apartments. I will show you some pictures later. So, but basically, this was the technique. And by what we know today, you could continue more. Why stop on 14 stories? Well, because the footprint of the building is so small that in the end, the wind will make the house shiver. If you made some other form of the footprint, maybe you could build higher. But this was the limit for this particular project. So we have the modules, we have the framework in laminated timber, we have CLT, and here you can see what is CLT. Well, that is laminated too, but here you change the directions of the fiber. So CLT is not so strong to carry loads through the construction. These CLT panels are taking their own loads, but they are not taking any other loads. And here we see we can make an elevator shaft out of it, we can make the staircase out of it, we can make the balconies, and all these things that is not taking loads from the rest of the building. And then you have the facades, the glass, and the metal. As I said, the glulam is carrying all the loads. But wood is a light material, so when you have a hurricane, 30 or if you have 100 kilometers wind on the top here, it will move a little bit. But it moves less than we expected. It's moving 71 millimeter. That's the flexing on top. And that is not much. We were actually afraid that people buying the top apartment would feel that they were living in a sailing boat. But they don't. We have had in experts from Cambridge University to measure in the storms, and they found that, wow, this house is actually moving exactly as the engineer calculated it to move. So we must have chosen a good engineer. But then, because it is a light material, we needed to add some weight. And we added concrete elements on top of the power floors in 5th and 10th floor. They are also working as the foundations for the next platforms, so that was suitable. But it was to add weight to the building. And then in the end, we also found that we had to add some concrete elements on the roof. And I'll tell you later, that was not a good idea. From what I know today, we would have been done differently. But we needed the weight added also there. We could have made these in wood, but instead of having them 20 centimeters thick, then you would have to have them 60 or 70 centimeters thick, and it wouldn't be too smart. Then you would end up with problems with the staircase and all this. So we choose to use concrete for this. This is a picture from one of the apartments. It's real. It's not made by some computer program. And here you can see beautiful big windows, but you have the fire alarm, you have the sprinklers. The sprinklers are inserted into the ceiling construction, so if they are needed, they will pop out and give the protection there. You can also see this is the connection between the modules. You can hardly see it. We choose to have a molding on the floor. The producer in Kodamaya, they suggested that we could wait until the building site to put this parquetry on the floor. But we said, no, this is to be made in the factory as much as possible, then we can live with a small molding on the floor. Another thing that was fascinating, when you make this power floor, how can you put these apartments in there? Because for the others, you just stack them together like Lego. Here, you first had the frame, and then you had to insert the modules in between the frames. And in the power floor, you actually have the frame visible in your living room, the connection point between the modules. So we wondered a lot how to solve this. Here you can see the structure. Down here, first the structure came, and then we had to put the apartment module inside it. This is how it looks from the inside of the apartment. You have actually this visible glulam construction. And some people say, I cannot buy an apartment where I can have this. It is stealing half of my living room. So we found that, okay, then we have to make a smart thing. We are making this dining table. So by this way of doing it, we could make a way to use this area as well. And as you saw on the other picture, there were no visible glulam structures, no nothing. This could be any apartment in any building, but here you know every day I'm living in the tallest timber building in the world. So the board leader of Moelven, when he was visiting, he asked me, Ola, how did you put the price on this one? What's the cost of this apartment compared with the others? I said, it's more expensive, of course, because it's more exclusive. So you have to believe in it. Another thing is that when you are making modules like this, you can not put in some modules in the structure. You get a hole like this. Remember, this is the platform construction. So by not putting in 2 modules here, you can actually do something else. So we made a gym in the 9th floor. It wasn't that smart, but we had to change some of the constructions on the floor. You see here, we had to put on machine foundation, stop the shiver down to the apartment below. It was vibrating too much. But now we have fixed it and it's actually working. So you have a tremendous gym with a fantastic view over the city when you're running on the treadmill. Then about fire. Wood burn, we all know. But if we try to put a piece of wood, 2 big pieces of wood into our fire, we will find out it stops burning. And now this is from Canada. They did a test on these CLT panels, and they found that they are very good when it comes to fire. They behave like we expect them to do, and using wood in itself is not a specific risk to fire. This is also now from Moelven done a full-scale test of a beam, and they find that actually it is not losing the capacity for the construction, even if it's burned. So wood is fully possible to use in tall buildings as long as you know what you're doing and you make the details right. And the reason is that wood will, you saw also on the pictures of Eva, wood will get burned into 3, 4, 5 centimeters, and then it will stop burning because there is no more oxygen that can feed the fire. So wood is definitely a material that we could use in high-rise buildings. It is not pre-accepted, so when we do the structural fire design in Norway, we have to make documentations. We have to make documentations that products are okay, that the solutions are within the regulations when it comes to fire. And the design is made based on the Eurocode 1995, which was the first Eurocode which opened the possibility to do it this way. Visit from Switzerland just 2 weeks ago, and they said that in Switzerland it's not allowed, it's forbidden to do like this, because they have not taken Eurocode into their regulations. But in Norway and elsewhere in Europe, it is allowed to do it if you can make documentation that you are following the rules. And when we constructed this building, the main important thing was to make sure that if you have a fire, people can escape safely within the time limits made for that. And all these glue lamp structures will allow to burn for 90 minutes without failing. And the modules also, we made Kodamaya reinforce them, so they will also take a 90-minute fire without spreading to the others. And actually, we've made calculations that indicate that the fire will stop within 1 module before spreading to the others. So we feel quite safe about these calculations. But then, the steel connections, because all these wooden frames, in all the joints, there are steel connections. They are hidden inside the wooden structures. I will show the details later to make sure that the steel parts does not become the weak part of the construction. And of course, we have sprinklers. Everything is sprinkled, absolutely everything. So you see here in the staircase, sprinklers on the balconies, and we even have a separate pipe system for the fire hoses. And I've said, God forbid that they ever connect a fire hose to this, because if you put some 1,000 tons of water into this building, it may just have burned down as well. You have to tear it down if you fill this house with water. But I hope it will never be used. And you also can see here that it is painted. We've used fire painting, as I call it, to stop the fire from spreading through the surface of the construction. So the engineer said, Ola, in this project we have used every single technique that is possible for fire protection. And I said to him, you must never tell me. It sounds very, very expensive, but it is safe. And here you see the detail of the joints. Here, these steel plates, then they are 2.5 millimeter, like shoestrings really, in here, and they will expand. So if the temperature rises, they will seal off every gap to make sure that the fire cannot get into the steel plates. And then we had another challenge on the outside, because as you noticed, when the wooden structures are outside the modules, then on these wooden frames, they are 50 centimeters wide. So there becomes a lot of air gaps on the facade between the cladding and the module. And then we found that we have to close that gap, so we are using these rock wool elements on the facade, which is then closing up the gap, and at the same time rock wool is a fantastic product because it doesn't burn. And then we had accepted that if we can seal off on the structures, the glue lamp structures, if we can seal off these triangles so that the fire would not spread here, then we would have what you almost could say was a standard situation. Normally we seal off one floor like this, but if we could seal off those triangles instead, we would stop the fire from spreading. And then we found this project. I believe it's a Norwegian product. It's called Securo, but I guess you also have it here in the Czech Republic. It's also expanding. So when you install it like this on these glue lamp frames, and when it expands, it will seal off every triangle so that the fire will not be able to spread. And then you have the challenge with the windows. How can we protect the windows if you have a fire on the facade? So we made window casing. This is aluminum, but inside is fire, rock wool, inside this to prevent the fire from spreading through the box into the window frame. So we did a lot of development on the way. But if you put a lot of smart guys together, and ladies, you will find out that they manage. They will find solutions. This picture is from the first module installed. This picture is kind of iconic. We used a tower crane. We found that we have to install a tower crane for this because this is a crane operation, really. To make the tree was a logistic crane operation. And here you see the frame with the secondary load-bearing system for the cladding on the facade. And then this is the elevator shaft. The elevator shaft is 15 meters high. It contains of 4 plates of CLT. The CLT was made in a German factory called Merck, brought to Bergen on a truck and put together on the site here. We put it on the ground and we connect them together like this. But as you can see, the foundations for the stair is already installed in the factory in Germany. We were very sure of the height there, because wood is fantastically accurate, and you know how it behaves. The modules, they will be shrinking during the first year 3 millimeters. So during a year, this point will get down 1.2 millimeters, no, 1.2 centimeters. So we had to take that into account when we made this. But it's very accurate, and this day I had a visitor from America, a bit more fluffy than me. So it took some time to put on his shoes when we were in the barracks. And before he could put on his shoes, the elevator shaft was in place. So he missed it. And he was just so fascinated that it was possible to make a 5-story elevator shaft in 5 minutes, like this, put it in place. And of course, you can also see another detail here. To make sure that there is space for the glue lamp frame, we had to measure every corner of every module had to be in place. Otherwise, we could end up in the top that there was no place for the glue lamp. And we also measured the top of the elevator shaft. And when we measured it, it was 3 millimeter out of course. 3 millimeter, nothing. I mean, concrete people, they don't talk millimeters, they talk inches. So it's very accurate. And then lifted in the modules. Some major challenges. When you see and when you hear me speaking, you could almost imagine that this was easy. This was Lego. And yes, we made this Lego instruction, piece by piece. We had a whole book of drawings. What piece is next? And we made it in the computer 3 times before we found the right number of when every piece was to come. But I told you about the climate. As I said, this year it was raining more than ever. It was raining 3,076 millimeters. And that was the most rain in 1 year since Abraham Lincoln was shot in 1865. So it was a very, very wet year. But we found that even the CLT constructions were wet. They could handle it. As you see here, the modules, they were already completed in the factory, so they could take the water, no problem. And the top module here, we made the roof with a little slope so that the water coming onto it would run off. But the glulam structures and the CLT structure was more difficult to protect in the corridor. But we found that it could actually take the rain, it would dry out within 1 day or so, and it would not make severe damages. So that was another learning, that if you can make the tallest timber building in Bergen, you can make it anywhere in the world, no problem. And then logistics. As you saw, everything was coming on trucks, or the modules were coming by boat. And you had to make sure it came on the right day, because you didn't have a lot of space around you to store all these things. So we had 3 shiploads coming from Estonia, 3 boats with modules, and they were coming on one specific day, and you have to order them 1 month in advance. So we found that even if we worked faster than we believed, the second shipload didn't come until January anyway. So you had to plan it very, very accurate. And then the tolerances. I told you about the measuring. The distance between the glulam frames and the modules are 25 millimeters. So it was very important that producers of the modules were producing them very accurate. It was important that the producer of CLT did it very accurate, and so with the glulam as well. And then I told you about the shrinking. We estimated this shrinking 3 millimeters per story. The corridor elements, they are connected to the glulam, and the glulam is not shrinking, so we had to estimate exactly the right level of each corridor floor to be able to open the door of the apartment. So tolerances was important. And wood is a light material, I've told you about that. And the roof construction, when suddenly these concrete elements were needed on the roof construction, we had actually planned a different roof construction, and we had a hell of a job to find a way to take the loads of the concrete elements down to the structure. So we ended up with a stupid steel construction on the roof that was very expensive and very stupid. So next time we will do it a little different. Here you can see from the production hall of Moelven, and they actually produced all the Lego parts of the glulam structure. They put them together in the factory, all the 50 meters, and they measured the tolerances to be very sure that this is okay. Then they took it apart again, drove it to Bergen, put it together again. So it was actually made or connected twice. Here we are in Bergen, connecting them again, piece by piece, and then you come to the top here. And of course, you can imagine when you have these tolerances that I talked about between these frames, and you were to put these modules into those openings. It was very interesting and a bit nervous, I have to admit, but it worked out. Another thing was scaffolding. We used climbing towers with platforms that we could go up and down with. But then it was a challenge when you're working on the module wall. The platform must be here. And then you have a 50 centimeter glulam construction. So then the platform must be here. So we made an agreement with the Dutch producer of these that they made adjustable platforms, and we changed the width, the distances of the connection points. So these scaffoldings were all out of the book. Nothing was according to the book. So the Dutch had to calculate and calculate, but we found solutions for it. So also when it comes to scaffolding, this was very well engineering. Here is from one of the balconies. You can see the glulam structure here. Very nice view. All glass from ceiling to roof. This is a picture from the staircase. Here, all the glulam structures are visible, but painted with wire painting. And this is also a picture of the elevator shaft, lifted in. And here you can see the foundations. Here is the openings for the elevator doors. So it was accurate. This is the computerized picture that we made to sell this project to the politicians. This is how it looks in real. So not too bad, huh? This is another picture, and here you can see the glue lamp structures, because we were afraid when we had to make a glass facade that the wooden frames would not be as visible as we wanted. But you can see here, it is very clear, this house is telling a story. I'm the tallest timber building in the world. Same from the seaside. This is the computer picture. This is the reality, and you can see the structures very clearly. This is my favorite picture as an engineer, because here you see the joint, all the forces are coming in here. At the same time, it looks like a star. So I call it the star of the building. It's beautiful if you're an engineer. Then we had a Swedish photographer taking this picture. His name is David Valdeby. So this is how it looks on a beautiful winter night in Bergen. And this is from the seaside. So what have we learned? We have learned that prefabrication is the future, really. It's the future. It reduces the time on the building site, and at the same time, it is very accurate, high quality. So this was one of the goals, and it has been a major success. Then we learned that the devils are in the detail. This roof construction was, we planned everything. We planned everything except the roof construction. And we found that we didn't have focus on it until it was too late, and it ended up silly. So you must have focus on all the details. And then, how can we improve? Where can we go on from now? You can change the footprint to make it more stable. Doing that, my guess is you can make 30 stories instead of 15. And here you see a suggestion. If we make a 30-story, then you need 2 elevators, 2 staircases. You can move them out like this, corridor in the middle. You will have more apartments, improving the economy in the project. And there is no problem here. If you have a bigger site, you can increase with some more apartments in the footprint. So this structure will be possible to make in 30 stories, maybe even more. 100 meters should not be a problem for this kind of structure. And this picture is from Oslo. It's the barcode. Oslo is the capital of Norway. They don't have the self-confidence of the city of Bergen, so they have to do something else. So now they made this tremendous barcode architecture. It could have been made in wood. By the thing we know today, this could have been made in wood. And then you see the potential of wood structures for the future. This is my motto. When we started out this project, I discussed it with my former boss. I worked for 10 years in an engineering company, and he said, "Ola, are you stupid? Don't even think about doing this. This is not possible. You will ruin your career. Don't think about it." So my motto is, you have to believe that the impossible is possible. Then you can do whatever you want. Thank you for listening.